One of the easiest ways to break your app is by handling webhooks incorrectly. And this is especially true now that everyone's vibe coding entire backends in an afternoon. You ship something that works in testing, traffic spikes, and suddenly requests start timing out, your server slows down, and you're dropping events completely. And if those events are Stripe payments or user signups, that's a real problem. The issue is that a lot of webhook systems, especially the ones you get when you vibe code a quick MVP, process everything synchronously. The server receives the webhook and immediately starts doing heavy work before responding back. That works until multiple events hit at the same time. So in this video, we're going to build a proper asynchronous webhook pipeline from scratch. We'll use Stripe to generate real test webhooks, Redis as a queue, Postgres as the database, and split the system into two separate services. We're also going to deploy the whole thing using Hostman. We'll provision managed Redis and Postgres instances, connect our GitHub repo, deploy the apps, and then stress test the entire system to see if it can survive a massive burst of webhook traffic without dropping events. Before we start deploying things, let's quickly understand the architecture we're building because this is where most webhook systems fail. The easiest way to think about this is like a restaurant. Imagine a waiter taking customer orders. If the waiter also had to go into the kitchen and cook every single meal before taking the next order, the restaurant would completely fall apart once multiple customers showed up at the same time. And that's basically what happens in a lot of webhook systems. The server receives a webhook and immediately starts processing the entire job before responding back. So if Stripe suddenly sends a huge burst of events, your server gets overloaded trying to do everything at once. Instead, we want to separate receiving the event from processing the event. So the architecture we're building looks like this. Stripe sends a webhook to our API. The API immediately pushes that event into a Redis queue, responds back to Stripe as fast as possible, and then a separate worker service processes those jobs safely in the background and stores the results in Postgres. This is the same general pattern used in a lot of production systems because queues absorb traffic spikes instead of letting your app crash under load. Now, normally setting all this infrastructure up manually is kind of annoying because you need databases, queues, networking, environment variables, deployment pipelines, SSL certificates, and secure connections between services. So instead of configuring all that from scratch, we're going to use Hostman to provision the infrastructure for us and focus mostly on the application logic itself. So let's start by setting up the infrastructure inside Hostman. Inside the dashboard, head over to the Manage Databases section and create a new Redis instance first. Redis is going to act as our queue, basically the place where incoming webhook events wait until the worker processes them. I'm just going to keep the default configuration here since this is more than enough for our demo, but one thing I do want to enable is VPC networking. This keeps Redis isolated from the public internet, so only our applications inside the same private network can access it. Now, once Redis is done provisioning, we'll create a PostgreSQL database as well. This is where we'll store the processed webhook data permanently after the worker finishes handling each event. Again, I'm enabling VPC here because there's really no reason for the database itself to be publicly exposed. This is one of those things that normally takes a bit of networking setup on traditional cloud providers, but here it's basically just a checkbox. And this is honestly why platforms like this are useful for smaller teams or solo developers. You still get production-style infrastructure like managed databases, internal networking, automatic backups, and scalable services, but without spending half the day configuring Linux servers manually. Once both services finish provisioning, Hostman automatically generates all the connection credentials for us, including the internal host names, ports, usernames, and passwords. We're going to use those in the next step when we deploy the actual applications. All right, now that the infrastructure is ready, let's put together the actual applications. We're going to keep this part pretty lightweight. The first service is our webhook receiver. This is just a small node.js and Express app with a Stripe webhook endpoint. When Stripe sends an event, instead of processing it immediately, we push the payload directly into Redis and respond back as fast as possible. That part is important because Stripe really only cares that your server acknowledges the event quickly. If your endpoint times out or fails to respond properly, Stripe will retry the event later, and under heavy load, that retry backlog can compound on top of the traffic you're already struggling to handle. Then separately, we have the worker service. This runs independently in the background and continuously listens for jobs from the Redis queue. Whenever a new webhook event appears, the worker grabs it, processes it safely, and stores the result inside Postgres. So now, instead of one overloaded server trying to handle everything at once, we've separated responsibilities properly. The API receives events quickly, Redis absorbs traffic spikes, and the worker processes jobs at its own pace. For testing, I'm also using a free Stripe developer account so we can simulate real payment webhooks and stress test the system later with a large burst of incoming events. Now let's actually deploy this thing. And this is the part where vibe-coded projects usually fall apart. You've got working code, but turning it into actual production infrastructure is a whole separate problem. Both of these services are already pushed to GitHub, so inside Hostman, we can head over to the app platform section and create a new backend application. I'll connect my GitHub account and select the repository. From there, I just pick node.js as the framework, which automatically sets up the right build and start commands for the project. No need to write any custom configuration. Then, under environment variables, we can securely inject the Redis and Postgres connection strings directly from the managed services we created earlier. This part is honestly really nice because we don't have to manually copy networking configs or expose database credentials publicly. Since everything is inside the same VPC network, the services can communicate internally. Now, I'm going to deploy the webhook receiver first and then repeat the same process for the worker service. Once deployment starts, Hostman automatically builds the applications, provisions the containers, assigns HTTPS endpoints, and handles the SSL certificates for us automatically. So we don't need to touch Nginx configs, reverse proxies, or manually configure HTTPS just to get Stripe webhooks working securely. And after a couple minutes, both services are live and running in production. Now for the fun part. Let's try to break it. I'm going to use the Stripe CLI to fire a huge burst of test webhook events at the server all at once. Normally, this is where a lot of smaller webhook setups start failing because the server tries to process every request immediately and eventually gets overwhelmed. But if we look at the logs here, you can see the webhook receiver is responding almost instantly because all it's really doing is pushing jobs into Redis. Meanwhile, the worker service is processing those events separately in the background at a steady pace and storing everything safely inside Postgres. And this is basically the entire advantage of queue-based systems. Even if traffic spikes suddenly, the queue absorbs the load instead of letting the application crash or drop requests. The jobs just stack temporarily, and the worker keeps draining them safely over time. What's nice here is that we didn't have to spend hours configuring infrastructure manually to get this working. Redis, Postgres, networking, deployments, HTTPS, and environment management were all handled directly through Hostman, which makes this kind of production setup way more approachable for solo developers and smaller teams building SaaS or AI products quickly. So hopefully this gives you a better idea of why asynchronous architectures matter once you move beyond small local demos. Vibe coding and AI tools can help you generate applications really quickly now. You can have a working prototype in an hour. But reliability and infrastructure still matter a lot once real traffic starts hitting your system. The code is the easy part now. The hard part is everything around it. And honestly, this is the kind of setup that would normally take a decent amount of DevOps work if you were wiring everything together manually. Here, we were able to provision managed Redis and Postgres instances, isolate everything inside a private network, connect GitHub deployments, configure environment variables, and deploy production-ready services pretty quickly using Hostman. So if you're vibe coding SaaS tools, AI apps, agents, automation platforms, or basically any backend project that needs production infrastructure without spending forever configuring servers, definitely check them out using the link in the description. They're also giving viewers a promo code that doubles your initial deposit, which is honestly pretty useful if you want extra runway to experiment with projects like this. That's pretty much it for this video. If you enjoyed it, don't forget to like and subscribe, and I'll see you in the next one.